Hey guys, in this video, we're going to run a simple linear regression analysis using Excel. So first of all, I'm going to go over the example presented in our PowerPoint first. So we get a house price here on the left column, and on the right column is square footage of the house. So first of all, we're going to create a scatter plot based on this data set. So go to Insert. Okay, under Insert, you're going to see this scatter. Okay, so we're going to pick the first option right here. Okay, now once you have that, you're going to see an empty table. That's okay. Okay, empty graph. Okay, click on select data, okay, and this window pop up. So you're going to click on add. Okay, now series name, we just basically the title for the chart. So we're going to do predict house price with the size of the house. Okay, and then X values, you're gonna highlight all the X values on the numbers only, no titles, just numbers. Okay, and also highlight all the Y values, series Y values. Okay. Highlight all those Y values, and yeah, click on that. You should be able to see a scatter plot right here. Okay, and also the title be presented there. So let me just format that a little bit. Load it. Okay, that's good. Size is good. So we're going to go down to maybe make it slightly visible. Okay. Also, if you click on the graph, you can go on top, right? Pick design from the top. You know, we can pick this design, for example. I guess I'll focus slightly. Yes, this one. Okay, this design. Okay, and now here, so you get this graph. Maybe I'll change to some other colors. It's better. Yeah. And cross all that, and click on plus sign. You can put in the axis titles. On the horizontal axis, we put in the square footage of the house. Okay. And again, I'm gonna just modify a little bit. Okay, 12, different color. Okay, recognizable. Okay, and then the vertical axis, I put in house price. Thousands, right? That's important. The unit is very important. So make sure you pay attention to unit. Okay. Highlight that. This. So it's good. So far we get a good graph. Also, you're gonna couple more things. We're gonna put a trend line here. Check the trend line here. So we're gonna see. We're gonna feed in linear regression model. Click on more options. We feed in linear model. Scroll down. Display equations on chart and display R-squared on chart. And so we're gonna use that to double check our Excel outputs in a second. So from the graph, we do know the regression model. Also, we know the R-squared. So as you can see, we get a regression model and also the R-squared. So let me just highlight that a little bit. Put in different colors so we can distinguish them. Okay. So we're gonna look into that in a second. Right, and double check the Excel output. Right. So that's basically the scatter plot with some highlight. So play around with all these different kind of settings here. You can actually customize the graph you like. Okay. So that's the first part, right? Scatter plot. And now let's get all the Excel outputs. So one more time, go to data on top, and you're gonna see a data analysis on the side. And we are doing a regression. regression correlation, yes, regression, yes, that's what we want. So scroll down, you're going to see these regression options. Click on OK. Now one more time, we're going to put in the y values first. So click on this arrow and highlight all the y values, including the title. That's okay. And also input x range, x values. So highlight a second column here. So we are including the title. So check the labels. Confidence level 95%. That's good. We want 95% confidence. Output range, we're gonna just put in underneath the idea, right? Just put it underneath the table so we can go back and forth. And also we're gonna also get a residual plot. Okay, so we're gonna analyze the residual plot a little bit, right? So check the residual plot on the next section here. All right, so that's pretty much what we need, right? So then click on OK. I'm gonna see all these Excel outputs. So let me just quickly format this. So now we're gonna quickly run through the analysis step by step. So this is what we call the Excel summary outputs. So here R, that's a correlation coefficient R, right? So this tells us some information, which is first of all, it's a strong because it's bigger than 0.75, so it's strong and direct. It's positive, so it's direct correlation relationship. Okay. The first thing, and also R square. So in terms of interpreting R square, we would say that 58.08%. Okay, 58.0% of variation in house price is explained by the variation of the size of the house or square footage of the house. Square footage okay, so that's how we interpret the R square. And the standard error and the standard deviation between the two variables and the sample size. I mean, sample size equal 10. That's what we know from the summary output. Okay, and if you look at the ANOVA outputs here, so we're going to analyze that a little bit as well. So let me format it. Center everything. No borders. So as you can see, F value is fairly large. So the P value, this is P value. I'm just putting the P value. So P value is 0.01. That means P value is much smaller compared to alpha. So that means that P value is smaller than alpha. So alpha is always going to be 0.05. Alpha equal to 0.05. For the entire semester, we're going to stick with the 0.05 for alpha. Okay. So that means we're going to reject HO. That being said, so there's a significant linear relationship between the house price and also the square footage of the house, the size of the house. Okay, so that's how we interpret this F value and P values. Let me just highlight that. Okay, so get that. And also, next thing is to come up with the regression models from this. Okay, let me just put it into the borders. Okay, so the regression model. So a simple linear regression model. So basically we have a predicted y values. So down a little bit. So predicted y values. Just say predicted y value. Predicted y. Okay. and that's equal to B0. B0 is 98.24. A3. I guess 4 decimals would be good. Let's just make sure it has 4 decimal. Adding B1, which is 0.1098, right? Multiplied by square footage. Here, so basically predicted house price equal to this 98.2483. That's the y-intercept adding the slope 0.1098 times the independent variable square feet, square footage. Square footage. Okay, that's basically the regression model in the actual context. Okay, so get this. Now if we go down here, so we basically have a, let me get a residual plot. Yes, I'm going to try the residual plot. Okay, the residual plot doesn't come out. That's okay. It should come up somewhere. Yeah, it's right here. Okay, so I'm going to drag this residual plot down. Drag it down a little bit. Drag it underneath. Okay. Here, so I'm going to put in side by side, right? Residual plot. Okay, so this is a residual plot. As you can see, it's bounded by a region. So first one, I'm going to format this. And if you look at the residual plot here, first of all, it's bounded in the region. So the errors are randomly located, right? So meaning errors are independent. So errors are normally distributed. Also, errors have the equal variance, right? That's what we can see from this residual plot. Okay. And so those three assumptions are checked, right? And basically, all this residual plot come from the residuals, right? Residual is basically the predicted y values, right? Predicted house price based on the regression model minus the actual. So basically, the first x value here it's 245. So 251.9231626. Subtracted from the 245, we get negative 6.9. So if we do this, taking this number here, and then go down to minus this number, predicted house price, like this, right? So this is how they end up with all the residuals, right? So you can just drag it. We can quickly confirm this, all the residuals, and then basically we just plot in the residuals on this to verify those three assumptions. So basically, first one, errors normally distributed. Secondly, errors have the equal or constant variance. And third thing is errors are independent because you see the random plot of the errors residual plot. Independent. So three assumptions, we check those, they all good. That means there's a significant linear relationship between the house price and also the square footage of the house. All right, so that's a Excel output from the for the first examples in our PowerPoint. Okay, submit. So down below here, there are another 4 data sets, right? I'm going to pick another one called pet food. I'm also going to run through the analysis really quickly under the pet food. Okay, so for the pet food, we have a shelf space and the sales. So a marketing manager of the large supermarket chain would like to use shelf space in terms of square feet to predict weekly sales of pet food. Again, I guess in hundreds, right? To be more specific, it should be in hundreds. So I'm gonna quickly fix hundreds. Probably that will make sense, or maybe in thousands. So in that case, we'll have this unit available. All right, so now we're gonna run through the analysis step by step. First of all, we start with the scatter plot. So now here, the shelf space determines the sales. So the independent variable should be shelf space. So I'm going to insert here dependent variable and dependent variable. So sales depends on the shelf space. That makes sense. So very important thing is when you first start on analysis, you want to make sure those two variables are clearly spelled out. Also, they are realistic, right? Basically, in real life, it makes sense. So we're using the shelf space in square footage to make prediction about the sales of the pet food. I'm going to insert, and then again, go here. You're going to look at a scatter plot. Okay. You're going to see an empty graph. That's okay. Then click on select data. One more time. Add series name is predict sales of pet food. Using the shelf space. So the series x values, so x values here will be the shelf space. So just highlight all those numbers. And then the y values is going to be the sales. Okay. All right. And you're going to see the scatter plot here. Okay. And again, I'm going to pick a design here. Let me see if you want to. Okay, I'll pick this design. All right. And again, I'm going to put in the horizontal axis and the vertical axis titles. So the horizontal axis is going to be shelf space in square feet. And on the vertical axis, we're going to put in sales in hundreds, right? Yes, I'll just put those. So we nail down those independent variable and a dependent variable on the scatter plot. Now again, I'm going to go here and click on the graph anywhere in the graph, and then click on plus sign. And under trend line, I'm going to go to more options. I'm going to put in a linear model. We're feeding a simple linear regression here. Scroll down, we're going to see display equation, display R square. And those two are important elements for this for analysis. So that's why it's always helpful to have it available here. So again, I'm going to make it available. Make it, change the size, and put in different colors here. And load it. Okay. I'm going to use it to double check later, double check our Excel outputs. So now I will get that part done. So we know from the graph, it should be a strong and direct correlation, right, between those two variables. Right? As shelf space increases, then the sales in hundreds increases, right? That's what we see from the graph. And now let's get all the Excel outputs. So go to data analysis. Okay, we're doing regression here. Click on OK. And again, we're gonna picking all the. So first one is putting the Y values. Y value is the second column, all the sales. Okay. So make sure, right? If you messed up X value and Y values, then all your outputs will be off. And the X value is going to be the first column, which is shelf space. And labels, confidence level is always 95%. Output range, we check it and I put it underneath it. Somewhere here. On B20. And then also we're going to get a residual plot, right? And analyze residual plot in a second. Okay, and click on OK. I'm going to see, so this is our residual plot. We're going to need it below that. So I'm going to drag it a little bit. So right here. Okay. So everything ready. So first of all, we're going to look at the summary output. First place to start analysis here. Center, okay, that's good. Now I'm putting all borders. So first of all, R is 0.827, which is greater than 0.75. So again, we confirm that it's a strong and direct, a strong positive. You can put positive, that's okay. Correlation or relationship. So we see that part, and also based on R squared. So let's interpret R squared. So R squared is 0.6839. As you can see from the 0.6839, R squared from the scatter plot will be the same. So 68.93%, no, 39%, 68.39% of the variation in sales is explained or interpreted by the variation in the shelf space, our independent variable shelf space. And that's how we interpret R squared. And then standard error, right? Standard deviation here between those two variables. And the sample size equal 12. We have 12 different stores being surveyed. Okay, so then secondly, we look at the ANOVA outputs. So one more time. Format this a little bit. Okay. Everything about this. So as you can see, F value is very large, 21.63886. And we're gonna do also yes, so p-value, actually this is p-value. Just change the p-value. So p-value is much smaller than alpha, as always alpha equals 0.05. 95% confidence, so alpha is 0.05. So the p-value is less than alpha. So that means reject HO. So there's a significant linear relationship between those two variables. That's what we have from this answer. Significant linear relationship. Between X and Y. Between the shelf space and sales. So the null hypothesis here is the relationship is there's no relationship, and an alternate hypothesis there's a relationship. So based on this, since we reject HO, so let's see the linear relationship between shelf space and that's it. Okay. And also, if you want to confirm R square, you can do sum of the square regression, right? So R square also could be confirmed as sum of the square regression, so equal to this over sum of the square total. Okay. So this is something we can directly get it from the ANOVA outputs, right? So that sum of the square regression sum of the square over total sum of the square. That's what we learned from the top point. So that confirms with this. Let's see, they're the same. And now let's scroll down to this. Continue on this. We'll just quickly format this. All orders. So I probably need to resize it a little bit so you can see all the coefficient, everything. So first of all, let's write out the regression model, right? Our simple linear regression model. So basically, the predicted sales equal to intercept with 145, adding 7.4. That's a slope, meaning when the shelf space is increased by 1 square feet, then the sales will increase by 7.4 units, which is $740 in the 300s shelf space. Okay, so this is the regression model. Also, if you look at, we're also going to analyze this shelf space slope B1, right? Test for t-test B1. So if you look at the t-statistics of the p-value, so the p-value is much smaller than alpha. So the p-value here it's smaller than alpha. So that means we reject HO. And reject HO means beta y not zero. So shelf space is a significant predictor of sales. Meaning that's a strong. So the shelf space have a significant impact on the sales based on the t-test here, or the p-value is very, very small. Just highlight that. And also we get a confidence interval here, so I did some calculation from the PowerPoint, so you can look into these numbers like using B1 and critical t-scores from the t-table, and also the standard deviation, standard errors, right, to get the calculation of the intervals here. Okay, so we finished this analysis of the ANOVA, also the come up with a regression model, and also if you look at residual analysis here, just format that a little bit. I'm putting all borders here. Okay, so one more time, all these residuals is calculated by using the actual y value from the original data set minus predicted y value, predicted sales. Right? For that. And if you look at how we get 182 here, so for the observation number 1, The shelf space is 5 units. So we're gonna plug into the 145 caddy 7.4 times 5. That's how they end up with 182 here, predicted sales. The difference between the predicted sales and also the observed sales and also the predicted sales, and that turned out to be the residuals. And try to minimize residuals. So you do 160 minus predicted sales 182, get that, and you can drag it to get the rest of them fairly easily. Now it should be exactly the same as what Excel gives us, but if you want to do it by hand, it is totally doable. I'll just confirm that same. And then let's look into the residual plot, right? I'll check all three assumptions here. So first of all, as we observe from the residual plot, so it is bounded in the narrow intervals, right? So first of all, errors normally distributed. Secondly, errors have equal variance, have constant variance. And thirdly, errors are independent. You're going to see a random plot there, errors independent. So that means there's a linear relationship between the shelf space and also the cells. So basically complete analysis, also go over all the detailed calculations, verify those numbers step by step. I will post this solution menu on in our blackboard course in a second when I finish producing this. And that's pretty much everything on the simple linear regression. And also, you guys can play around with it. We have 3 more data set here. If you want to play around with it, try that yourself. Not a problem. Okay.